Welcome to This Is My Architecture. I'm Matt from AWS. Today I'm joined by Tom from Accenture. Thanks for joining.
Glad to be here, Matt.
So tell me about Accenture.
So I work for the Accenture Cloud Platform, which is Accenture's cloud broker offering.
Okay.
We help clients get their workloads from data centers into the cloud or native cloud applications or even hybrid cloud applications. Accenture Cloud Platform gives them the tools to have governance around that, do cost analytics on their stuff, and generally browse and manage their estate.
Okay, so I've been working with Accenture for a long time. I've had that privilege at AWS, and you work with some really big customers, right?
Biggest customers in the world, a lot of them, and they have lots and lots of accounts and lots of resources in those accounts.
Yeah, not only that, but they have environments in AWS, they have environments on premises, their infrastructure and services are spread all over the place, right?
That's correct.
So this effectively allows them to have visibility across all their environments, right?
Right. We don't like to say single pane of glass because it's not.
Yeah.
We have a coexistence model. So if they want to go into the cloud provider console and provision resources, we want them to do that. That's just fine. And then we discover those resources that have been created and display them back to them in our own tool inside of ACP.
Okay, cool. So that's what we're going to talk about today, right? The ability to discover those resources as they get created.
That's right. So once a client has brought their account to us or provisioned account through us, then every 10 minutes we'll use CloudWatch to trigger what we call a discovery run.
All right.
So CloudWatch will call through our discovery API and ask to discover all of the resources for a given account in a given region. And so what that does is it triggers our dispatcher to then start requesting each of the different resources for that account in that region.
Okay, yeah, I was going to ask why you kind of had two layers. So you have a sort of a web service call that comes through API gateway that triggers a Lambda. But why do you have these multiple layers?
So the second layer here, where we fan out, is to be able to discover each different resource type independently. Lambdas, of course, are short-lived, right? So you want to go do something quick, come back with your result, and then move on to the next thing. And so what happens is that result then is dropped into an S3 bucket, where it can be picked up for later processing.
And I guess that allows you to move a lot quicker too.
It's really fast when we run it, yeah. Each discovery run for a given account operates within seconds.
Okay.
And so then that can drop everything into S3. And then what we do is we pick that up with a different Lambdas, which is triggered off of that S3 bucket. Let me draw that with arrows. So it picks up what was discovered, and then it does a difference against what was already there, what we knew about from that account before. So if you've gone in and provisioned, say, a new EC2 server, then we'll see that there's a new EC2 server.
So how do you know, where is the previous state stored?
That's all stored in S3.
Okay.
And then the differences are stored in S3. And then yet another Lambda picks up those differences and makes the updates into Elasticsearch, where we store the actual records about the resources themselves.
So that's where users or programmatically you can query the search engine.
Absolutely. For example, we do governance, and so our governance engines, our policy engines, will run across Elasticsearch, pulling back out of our what we call our inventory API, which is also driven through API Gateway, and we'll be able to detect anything where a policy is being violated or a best practice isn't being implemented. But independently, through Accenture Cloud Platform's dashboards, you can go in and just browse your estate and see what you have out there and use our cost analytics to see what it's costing you.
Oh, that's cool. So give me an idea of the scale of this. We were talking, these are very large accounts. Are you discovering how many Lambda functions are running in parallel? Is it 2, 10s? What are we talking about?
We can run probably 3, 4, 5,000 Lambdas at a single time.
Wow.
So yeah, we had to definitely call in and get our limits raised for concurrent Lambda runs. But each Lambda is very, very quick. And so even though we're doing this across hundreds of accounts, we really don't max out above maybe 3,000 or 4,000 Lambdas running simultaneously. And then they all quickly are depositing their results into S3.
Yeah, so when you're running at that scale, now it makes sense why you're using S3, because it's going to be really, really spiky, and that's a lot of data, a lot of sort of parallel writes, and S3 can handle that, right?
It absolutely can handle that, and then we're, it's right there for the next thing to pick up. Previously, we used Kinesis for that, and we found that while that works great for some things, we wanted to switch to S3 because it gives us just a much bigger, easier place to drop a blob into, and that's what we're doing now.
Very cool. So it truly is a fan-out method. There's a lot of Lambda functions on here. I really like how you've decoupled the architecture, how it's serverless. It takes really a microservices-based approach.
It really does.
To discovery.
Yep.
So it's a great architecture. Thanks for sharing it with us.
You're welcome.
And thanks for watching. This is my architecture.